Good day, everyone. This session we will cover Chapter 6, the normal distribution. Remember in Chapter 1, we learned about quantitative variable. For quantitative variable, there are two types, discrete and continuous. For discrete variables, we have the discrete distribution, which you have learned in Chapter 5. There are two types of discrete distribution, which are the binomial distribution and the Poisson distribution. In this chapter, we will focus on the continuous distribution, which is the normal distribution. Of course, there are many types of continuous distribution, but in your syllabus, we only cover one type of the continuous distribution, which is the normal distribution. In this chapter, you will learn to compute the probability from the normal distribution. In other words, you will be given the x value and you need to calculate the probability. Second, you need to know how to use the normal distribution to solve the business problem. Third, you will need to use the normal probability plot to determine whether a set of data is approximately normal. So previously, you have learned a few ways like using histogram, compare the mean, median, mode, etc. to check the normality. So now we just summary here what are the methods available to check for normality. Continuous probability distribution. Continuous random variable, as you have learned earlier, is the random variables that can assume any value on a continuum, can assume an uncountable number of values. So continuous probability distribution, as I told you earlier, you have to use some instrument or device to measure. For example, like the weight, the mass of the item, temperature, height. So all these measurement, all these variable, you need to use some instrument or machine or device to measure it. So the data that you read are actually continuous data. So normal distribution, we have a bell-shaped curve. As you have seen earlier, the center there is actually the mean, median, and mode if they are follow a standard normal distribution. So normal distribution, they are symmetric, meaning that if you put a mirror at the center here, they will be identical. And the value for this x-axis is from negative infinity until positive infinity. Another way to check whether it's a normal distribution or not, you can take the third quartile minus the first quartile, and it's actually equivalent to 1.33 multiplied with the population standard deviation. But most of the time, we don't know the population standard deviation. Mu here is actually the location. You have learned about the mean, mode, and median. For the spread, we usually use the standard deviations to measure it. So for normal distribution, you have two parameters. One is the mean, another one is the standard deviation. I have uploaded two videos to show how to randomly plot the normal distribution using the SAN and also using the simulations device. So you can look at the videos in the e-learning portal. Normal distribution, we have this formula. In your formula, again, the two parameter is actually the mu and also the sigma. Don't worry, you don't have to memorize this formula. We will not use this formula to do the calculation. Let's go into the detail for normal distribution. Suppose the age of an employee in industry A, B, C are normally distributed. So you have in the mean for the industry A, B, and C respectively, also together with their standard deviation. If we try to plot these three items using the normal curve, this is what you see when we compare the industry A and industry B. So if you observe here, the mean population mean for the industry B is 36. The population mean for the industry A is 42. So in this scenario, your A and B have the standard deviation of 5 years. If you look at their curve, if you put them overlap, they are actually identical. So sigma is the same, but the mean is different. You will see this kind of comparison. What about if the mean is the same, but the standard deviation is different? So if you look at industry A and C here, both A and C, their mean value are 42 years, but their standard deviation are different. Industry A have standard deviation of 5 years, whereas industry C have standard deviation of 8 years. So if you look at the curve for industry A represent in the blue color and industry C represent in red color, you will see that industry A, the standard deviation 5 is more, have a peak here, but industry C with a bigger standard deviation, the curve is more spread compared to industry A. At the center point here, you can see their center location, which is the mean 42 years, are exactly located at the same point. So in other words, these two industries, they have the same mean value but different standard deviation.